Hello, this will be a video to go over domain and range of both continuous and discrete functions. So I'm going to list through kind of what we did in the notes. When you're listing domain and range, just points like here on this one, you are going to list them in order from least to greatest and don't repeat numbers. So remember, domain is just your x's. So for this one, we're just going to select the x values. We're going to go in order. So we're going to start with 4. We're not going to repeat the 4. Then we're going to go to 7 and 10. And then, of course, your range would be the y values. So you'll start at -2, then 5, then 8, then 11. Now, that's anytime you give a table, points, just graphs, whatever. It's going to list just like that. The kind of more challenging part of this lesson is looking at line segments, lines, parabolas, continuous functions. And for this case, you want to think, what could it be, what couldn't it be? So on any one of these, we have an infinite number of points on this line segment, right? You have like this point here, you have like this point, this point, this point, this point, this point, this point, this point. There's so many that we literally can't list them all. Remember, numbers can continue on forever, including behind the decimal point. 1.1, 1.11, 1.111, 1.11111, and so on. So, in that case, we are going to think, well, what could I have as my x's and what couldn't I have? And that's going to lead the conversation on how to determine what the domain or what the y's could be as well if we're talking about the range. So, on this one, what could it be? Well, it could be 2, right? X is 2 here. It could be a 1. It could be 0, -1, -2, -3. It could be 1.5 or like 1 3/4. How about like 1 9/10? So listing those, it could be anything that's between 2 and -4. You're looking in between those. What it couldn't it be? It's never going to be 3, right? Or 4, or really anything greater than 2. It's not going to be that either. It's not going to be -5. It's not going to be -6. All of those are kind of out of the reach. And you can think that way then too with these ones that have arrows on them. What could the range be? Well, if we're talking about the y values, it could definitely be 1, right? There's a y value of 2. There's one of 3. What couldn't it be? It's not ever going to be 0, right? It's never getting down here. Never going to be down here either. -1, -1,000. It could be anything that is 1 or above, but it's not going to be anything else below it. So kind of getting in those conversations in your head with what could it be, what couldn't it be. Now these were actually the one notes that we filled in during class time, so I'm going to go through those as well. For your domain on this one, it looks like we're starting at, is it -8? And then 4. On these, you just list them. You don't have to do these inequalities and descriptors and things like that. So -8, -4, 2, and 8. And your range is going to be -4. I'm just listing the y values. There's the y value of D. C is -2. B and A are both 8. So that would be your domain and range for points. But when it comes to the continuous graphs, you can't list all of them because there's an infinite number of points. And you want to look at the graph and think, well, what could the domain or range be? And also, maybe just as valuable, you could even kind of argue that it's more valuable. What couldn't it be? Because that's really going to tell you where your limits are. Just some strategies that I use and I'll use in this video for determining domain and range of these. Domain, since it's your x, we're going to be looking, sorry, I'm like really around. You're going to be looking from left to right. And as you move left, if you hit an arrow, and sometimes it looks like this, sometimes, it could look any of those kind of options. you're going to negative infinity. So once you hit an arrow going left, we know we're going to continue on in that direction forever. Same things if you're going right, but instead we're going to be hitting a positive infinity. And then for your range, you're going to look up and down. And if you hit an arrow going up, you're going to go to positive infinity. If you hit it going down, you're going to go to negative. So we're going to do some of these. We're going to kind of go through them a little fast. So sorry in advance, I'm just a little tired. So your x values for this line segment, you're going from, it looks like here, which is 1, 2, 3, 4, 5, 6. Going from negative 6 to, what's that, 1, 2, 3, 5, 6, 7, yeah, to 7. So your domain could be anything between negative 6 and 7. It's going to be everything, actually. And the way you would write that as an inequality is a bit bizarre because you have to write it using compound inequality. So it's going to be negative 6, and then x is going to be greater than or equal to that. So it's anything above negative 6, but at the same time it has to fit below 7. So that's kind of the method that we do the inequality. For your range, if you go up and down, it goes up to here, which is 1, 2, 3, 4, 5, 6. So you're going from 6 to, and I just always draw lines to the range, to the y-axis for the range to get better numbers. 1, 2, 3 to negative 3. So it's, again, it's between 6 and negative 3. And we would write that as an inequality. Kind of the same way, starting with a smaller number, negative 3, and using y as your variable since we're talking about the range. So those are the two line segments. We're going to do a lot of these together here. This next graph is going to be a ray. So the ray, our x values are going from, it's kind of starting here. When we move left to right, it stops at this 0. So we're going from 0 to positive infinity. So really, all of these are your x's. So here's 1, 2, 3, 4, 5. You know it's going to go there eventually, 6, and it's going to continue on. So it's really going to be either 0 or above. Oh, that's supposed to be down here. Sorry. That would be what your inequality is. For the domain. Since you're going to the right forever, we're heading and all of our numbers on the x are increasing in size. We go up and down. We're going from, we're talking about range now, so we're going down to, it looks like negative 2. And again, then we're going up and we smack that arrow up there, so we're going to a positive infinity. So it's going to be negative 2 and above. Again, you're going negative 2, there's negative 1, there's 0, and you know eventually it's just going to continue to increase in size. So for this one, it'll be greater than or equal to negative 2 for that problem. Alright, we're going to do the last, I think I have 2 more on here. I think I go graph for. So left to right, this is interesting. So if you go left, we're going to smack that arrow right there. So that one's going to be going to not negative 8, but negative infinity. And then this graph will be going to positive infinity. So I'm moving left to right, I'm hitting it. Then I'm going from this to this. This situation when you're thinking, well, what could the x be? It could be anything. What couldn't it be? Nothing. Everything is, the x is going to go in every direction, left and right continuously. So the words we use for that are all real numbers. And we continue to use that notation of the capital R, double R. So for the range, when you go up and down, you'll hit arrows going up right here, but as you're going down, it stops right at the negative 3. So you're going from negative 3 and up, so negative 3, and it's getting better, bigger, so to positive infinity, or negative 3 and above. So your range is not real numbers. And you can kind of think, the range will never be negative 4. It will never be negative 5. Use that logic to help reason through these, because they can be kind of tricky when there's so many points. All right, the last one, a line. So if I'm going left to right, I'm hitting an arrow here, and then I'm hitting an arrow here. So this is another one where it's all real numbers. You can put all real numbers or whatever, any number for that one. And then the same goes for when you go up and down, right? You're going from negative infinity to positive infinity. I'm hitting an arrow here and here, and it's going to be all real numbers. The last ones, I filled these in. I didn't erase them off. Or just some practice problems. But this one, the notation, usually the way they ask for these questions is usually in inequality form, in Algebra 1 anyway. So the notation is between the x values for this one, between negative 2 and 3. So the notation on that would be negative 2 is less than x, which is less than or equal to 3. The same thing with the range. The range is going from, and you always want to look at the y values when you're referring to the range, negative 2 to 4 for that one. Alright, for this one here, you're going left and right forever. I know it seems weird because it's heading down, but when you scroll your pencil side to side, kind of like this, I mean, this is a terrible pencil drawing, but I'll just show you so you can see me sliding it. When you go side to side, that looks pretty good actually. You're going to hit arrows in both directions. So that will indicate to you that your domain is all real numbers. And your range, I should have left the pencil because you can actually, I can like demo it on this part too. And it's more like a crayon now. I think I can turn it. Of course I can. Okay, no, it didn't last. I liked it turned better. Let me see. I'll try it one more time. No, it's mad at me. Okay. So anyway, when you, I don't know why it's not letting me turn it. No, there it goes. Okay. So then when you go up and down with this, you'll notice you go up to here, but then you go down forever. So that's why the is from 7, because that's its peak from the range, and then it goes down forever. I like that pencil. Now I'm going to have to use that more when I teach it. Alright, the last one on this was what the domain and ranges of this vertical line. The domain's only 7. It's never going to be 8 or 10 or 6 or anything below it. It's just 7. And the range, since it's going up forever, down forever, it's all real numbers. So infinite, negative infinity to positive infinity for that one. Okay, this was a long video, but hopefully it was helpful, and thank you so much for